Stoichiometry. Stoichiometry is a very important concept in chemistry, and chemists use it all the time when we're working out math issues, like we're figuring out our percent yields or determining how much of a certain reagent we need to use. Stoichiometry is basically the relationships between the substances in a balanced chemical equation. And it could be a reactant to another reactant. It could be the relationship between the more than one of the products, product A to product B, or it could be the relationship between a reactant and a product. And we get the relationships from the balanced chemical equations. Balanced chemical equations are important because of the law of conservation of mass. We know that matter is neither created or destroyed. So when you have a closed system, if you have a beaker or a flask that is closed, like it has a stopper on it, and then you have a reaction inside, so you have reactant A and reactant B, the mass will be the same as your product. Maybe you have product C and product D. But because you've got the stopper, no matter can escape, and the total mass of your reactants is equal to the total mass of your products. So that's this law of conservation of mass. That's why we balance chemical equations. Each atom has a specific mass, so the same number of them are afterwards as there are before. So let's write a relationship using the equation for the formation of water. So in this chemical reaction, we could say two molecules of water are formed from two molecules of hydrogen. We could say one molecule of oxygen reacts with two molecules of hydrogen. So the first example here is a relationship between one reactant and the product, and the second example is between two reactants. We could also say 2 moles of hydrogen react to form 2 moles of water. We can also say 2 moles of hydrogen react with 1 mole of oxygen. So we can talk in terms of molecules, which are too hard to count because we can't see them, or we can talk in terms of moles that we can measure. So, and we can write these as ratios. Ratios look like fractions. So we can say 2 hydrogens require 1 oxygen. And you can flip that and say 1 oxygen requires 2 hydrogens. The relationship is the same. The number is different. 2 divided by 1 is different than 1 divided by 2. But the relationship is the same. 1 oxygen to 2 hydrogens. For hydrogen and water. And don't reduce these. keep the coefficients from the balanced chemical equation in there. Don't reduce these 2's. Okay, don't reduce these 2's. These ratios are extremely important to a chemist. We use them a lot, and we have a name for them. These are called mole ratios. And whether you use formulas moving forward or dimensional analysis, both methods will need to use these. So you're going to have to get used to taking substances from your balanced chemical equation and writing them as fractions or ratios. Okay, so here's a balanced chemical equation. 2 aluminums react with 3 bromines to form 2 aluminum bromides. All right, how many moles of bromine are required to form 5 moles of aluminum bromide? What you want to do is start off by putting what you know under the substance that you know it about. So we know we've got 5 moles of aluminum bromide, so 5.0 moles. And then put a question mark under what we're trying to figure out. So we're trying to figure out how many moles of bromine. So there's a relationship between bromine and aluminum bromide. So you can either write 3 moles of bromine to 2 aluminum bromide, or 2 aluminum bromide for 3 Br2s. Same relationship, just we've flipped them, we've inverted them. Okay, which one of these you need that you're going to use depends on what you're trying to figure out. The ratio that you're going to use is going to be the one with your unknown on top. So we want the one with the bromine on top. So 3 bromines over 2 aluminum bromides. And then you put a times. And then you put what you do know, your 5 moles, and put your units in aluminum bromide. So this way, because aluminum bromide is on the top of the second number and on the bottom of the first, so it's underneath here and it's up top here, they will cancel. Your units will cancel. So aluminum bromide cancels. We're left with 5 moles and 3 N2 and Br2. So now you do the math on the numbers. 3 times 5 divided by 2. So you multiply any number that's on top, divide by any number on the top, on the bottom, and then your units are now moles of Br2. So you get 3 times 5, 15, divided by 2, 7.5 moles of Br2. So you multiply your mole ratio by your known substance so that your known substance cancels out, and you're left with moles of what you want to find. Next example, how many moles of ammonia can we make from 2 moles of hydrogen? So we know we've got 2 moles of hydrogen, and we want to figure out how much ammonia we can make. So we know that 2 ammonia are made from 3 H2. So 2 moles of ammonia made from 3 moles of hydrogen, or 2 molecules of ammonia are made from 3 molecules of hydrogen. And we put a multiplication sign in, and we know we have 2.0 moles of H2. You have to put your element symbols in here because they are part of your units. So hydrogen is going to cancel. We're left with 2 times 2, right? Anything on the top multiplies number-wise, so 2 times 2, and then divide by 3. So if you're on the bottom, you're doing division. So that is 4 divided by 3, so that's 1.3. And the units are now moles of NH3. So we figured out we will make 1.3 moles from 2 moles of hydrogen. Now this is a mole ratio, not a mass ratio. So you're not going to get masses this way. You would have to figure that out separately with molar masses. Okay, so next question says how many moles of nitrogen will be required? So we've got another question. So nitrogen. How many moles of nitrogen will be required if we use 2 moles of hydrogen? So the ratio is 1 N2 for every 3 H2s times 2.0 mole H2. H2 cancels, so now we're left with 1 times 2 divided by 3. So 2/3 or 0.67 moles of N2. So 2 moles of hydrogen will require 0.67 moles of nitrogen gas. And that's basically stoichiometry. You take your balanced chemical equation and you make a mole ratio. And you use that with multiplication to convert from one substance to another substance. And we're going to be using this a lot in chemistry math calculations.